In this video, we'll look at wholes of rational functions. So up to this point, we've looked at rational functions and assumed that both the polynomial in the numerator and the denominator do not have factors in common. If they do have a factor, it's okay for us to cancel that factor, but we have to be really careful about what's happening at that zero. So we'll look at a couple kind of motivating examples and give a formal definition of wholes when you have a common factor in the numerator and denominator. So we'll graph both the function s of x equals x minus 3 over x squared minus 3x and t of x equals x squared minus 3x over x minus 3. So part of the reason why I wanted to use these two was because obviously they're very related. One happens to be the reciprocal of the other. But you get very different results when we graph each of these out. So first, let's look at s. If we factor the denominator, we can factor out x, so we have x times x minus 3. Now, we're allowed to cancel these two factors out. This is okay for us to slash through the x minus 3, so we're left with just 1 over x. But the problem is now that when we plug in 3 into s, we get 3 minus 3 over 3 squared minus 3 times 3, which is 0 over 0. This is one of our undefined forms, along with 1 over 0. So at these points, we have to be really careful. What you do next, after you cancel any common factors in the numerator and denominator, you can go on and graph like you typically would. We know that this one has a vertical asymptote at x equals 0 and a horizontal asymptote at x equals 1. On the left-hand side of the vertical asymptote, we slip by like this. On the right-hand side, what we'll do is at the point s of 3, using our new canceled form of our rational function, we'll plug 3 into that. So we have s of 3 equals 1 over 3. So we find that point right about here, and we draw an open circle, kind of like we would on the number line if we're excluding that particular value. Of course, we have to exclude that particular value because it is undefined. So in some ways, you can think of it just like you would an asymptote. And then once we have our wholes, we just draw it right along like we normally would. So that's what x minus 3 over x squared minus 3x looks like with a whole. Now for t of x, we kind of have a similar process. We can go ahead and cancel out that x minus 3. So we have x times x minus 3 over x minus 3, and we're left with just x. Again, we have to exclude the value for 3, so we can plug in t of 3 into our new form right there. So we just get 3 back out. So at the coordinate pair, 3, 3, we have a whole. So we find that, draw a whole, and then, just as before, we draw our line as we usually would. And just for, just to write it out over here too, here we have a whole at 3, 1/3. So wholes in rational functions. In the rational function, r of x equals p of x over q of x. If p and q have a factor in common, then we may cancel the factor, but only for the values of x for which that factor is not 0. That is to say that, in the example above, we had problems at x equals 3, so we could only remove that x minus 3 factor from the numerator and denominator and take out the values for x equals 3. Since r of x is not defined at that value of x, because we'd have r of x equals 0 over 0, the graph has a hole at that point. In the next video, we'll look at slant asymptotes of rational functions.